Hey everybody, Jeff here, CS161A. We're going to jump into Module 3 here and go through some of the stuff we're going to cover in here. Today, I think most of the time you'll be seeing me type and run stuff within Replit. So remember, you obviously could always pause the video and have a Replit window side by side and be doing what I'm doing. And if it doesn't work, you can go back in the video, you could pause the video, and you can kind of do this interactively along with me, if you will, which is what we would do is if we were kind of doing something in person, right? So Module 3 is about data types and math functions. We learned about data types a little bit so far in this class and in CS160. And with respect to math functions, we've learned some already, of course, how to add two numbers, for example. But we'll kind of jump into the conceptual piece of how this works, and it helps set you up for other library functions. And so, as usual with these modules here, right? You got, one or more pages, discussion, topic, and assignment here, and a summary page. There's also a mid-course survey here. I love this stuff, so feel free, please, take a moment and do the survey and let me know. I love feedback. This is something that might be different with me and some of your full-time academic instructors coming from and currently in technology development and product development. It's about getting feedback all the time, good and bad and neutral. So please do that if you would here. Before I jump in, see this comment here in italics here? Figure out how to divide two integer variables and retain the decimal portion of the answer. 5 divided by 2 is not 2.5, it is 2. That exclamation mark there is for the sentence. It's not the math operator. It's kind of could be confusing there. But we're gonna walk through this here in a moment here. But I wanted to show you this comment here. So if we jump into the overview, we won't talk in this video that I'm recording now, this comment about hand tracing. I'm going to try to get another video out early this week, maybe today, on how to debug using some of the tools to debug and tracing, and that may or may not cover some of this. We did hand tracing in CS160. You might remember that. I think that was lab 3 or 4, I think, where you hand traced. Hand tracing on paper or on the screen is super valuable piece of debugging, but I'm not going to cover it directly in this video here. We are going to cover a good number of these. I want to make a note here to make sure I cover a couple of these things here. Data representation, numeric data, both real numbers and whole numbers, and some character data. Okay, and so we'll be covering the book chapter 3 primarily here as we go through this. Okay, so I have the book open already. Data types and math functions is chapter 3 here. So we're just going to jump in. All right, let's start with this what I was talking about earlier as a teaser on that page here. So if I just want to create some integer variables here, I'm declared A and B as an integer, and I've declared C as an integer, and I'm doing a division of A divided by B. If we were in person, I would take a show of hands to see what people might get. So think about that for a moment. And let's run this, see what we get. We get 2. Okay, now this is a common bug that you will run into. You will try to be dividing this and you're going to expect 2.5, even if you declare this as a float. So let's try that. Attempt 2. And then we're going to say int C0, no, not int, double. Now if we run this, unused variable. Okay, gotta make sure I use the variable that I declare. I still get 2. Okay, and so this didn't work either. I was hoping to get 2.5 here, but this didn't work, right? Oh, but maybe I forgot to set my precision. Let's see what happens if I do that. I don't need to recalculate. I just need to reprint. Okay, now I get 2.00, which is even more confusing, right? So I still am not getting my 2.5 value that I want. All right, so let's keep going. Remember, C0 is already a double. Let's see what we get here. You start to think that, okay, maybe this will work, right? Probably would get 50% of you if I had a show of hands. And sure enough, it works. Okay, so because I'm taking at least one of these two as a double, at least one of these, this is going to perform, this divide symbol is going to do a floating point, or it's going to be doing a real number division. Okay, remember when I say floating point or double or real number or single precision, I basically mean the same thing. Now, note, float and double are technically different data types, but conceptually they refer to real numbers. If you don't remember real numbers versus whole numbers from your math classes, real numbers are decimal numbers, 2.5, 3.145, whatever, 3.1415, 9.999999, where integers are whole numbers. Okay. Okay, so now I got my correct answer here. Now let's do this. What if I don't want to do a, I don't want to use a variable to calculate that, and instead I just do this. I'm just going to do the math inside here directly, and that does work. Okay, and so, but did I do that already? No, I didn't do that already. Let's jump back. Let's do this. We might instead, we'll use literals here. So let's see what this does. Okay, that doesn't work. Okay, that does integer. if you look here, and maybe it's hard to see. Yeah, let's do this instead. Run that so you know it, so you don't have to kind of keep track of which ones are which here. All right, so you can see that the direct math, if you do the direct math, if you force one of these to be, one or both, to be a floating point data type, which is again either float or double, the divide operation will do floating point arithmetic and produce a floating point answer. Okay, so this, we've done half of that teaser problem. The second part is, well, how do we get the remainder, right? If we did integer division and we do 5 divided by 2 and we get an integer quotient of 2, where is that remainder? And I'll show you that here shortly. Okay, let's keep going. So now let's talk about some math functions. Okay. We're doing basic division and addition and multiplication. We've been doing that in these last videos. But sometimes there are math functions that are much more complex. For example, the square root, taking the square root of something. Very few of us, maybe nobody in this watching this video, including me, knows how to mathematically do a square root. We primarily learned how to do square roots via guess and check, right? A trial and error. Another example might be taking the sine, cosine, or tangent of a number, or very complicated logarithms. These are complicated math functions that you don't want to have to code out. Fortunately, they've been developed and they're in what's called a library here. Now, we've talked a little bit about libraries, right? These are libraries here, IOStream and IO manipulation. Those are libraries here. So we're going to add the math library. And this is another one of these that you could, I would say it's okay to keep in your code and kind of as your standard libraries. You don't want to put like every possible library in the world in every one of your codes, because it will slow down processing, the compilation, the memory. It'll make could make your program more bulky. It certainly makes the process more bulky. But this one is one that you're probably going to use more commonly, the common enough library. So we're going to do include CMath. Okay. So now let's start to use it. Now, first of all, okay, well, how do I find some of those math functions? So we go to our textbook here, right? Standard math library has about 20 math operations. Okay, here's an example using one called SQRT, which stands for square root. And so you can see in this code, we are giving it a number, a variable, and it's going to calculate the square root. Okay, so let's try that. Let's see if we can get that to work. Let's do 49 was the example. Let's pick another example. That should work. So square root of 121 is 11. Note that the square root took an integer input, but it created a floating point output. You can tell because it's got the 0.00 there. We're going to talk about how that happened shortly, because we showed here an example where this guy did not do that, right? There are lots of math functions you can use. These are 3 common ones. The square root, of course, we talked about. Doing a x to the y power calculation. The absolute value is another common one. And so let me show you that power one. Okay, think back to your early CS60 exercises, and you know the 2 to the 10. You're just going to basically double 2 a bunch, basically 10 times, or I guess 9 times technically. 2 to the 10 is going to get us 1024. You can go bigger, right? 2 to the 32 is going to be about 4 billion, right? 4,294,000, or 4,294,967,296. Okay, that's your 4 gigabytes, by the way, right? So that's very common in data representation. You can do math inside of math. Okay, so let's do an example using you can always embed these types of function calls within the function calls themselves. And so you can make your code, like you can combine different things and put them in a single line of code here. And so let me show you an example of that here. Okay. We're going to have A3 and B3 be a see, I'm already getting inconsistent being using double and float. I should try to use double for everything. A3 and B3 are the sides of a right triangle, right? So we are going to say length of the hypotenuse, did I spell that right? I think, is, remember your formula, it's the square root of side 1 squared plus side 2 squared. Notice that Replit added my extra closing parenthesis for me. This is something I don't know if you notice as I click around, right? You get a lot of help here from Replit to show you how your parentheses match, and that gets important as you start to embed things inside and things like I'm doing here. Okay, so let's run that. I forgot a semicolon on the end. And my length of my hypotenuse is 17.16. Feels about right. I'm sure the code is correct, but you can manually calculate this if you wanted to. You don't know, right? The problem is that this is getting to be complex. I wouldn't call it super complex, but if you have a bug in this line of code, it's difficult to debug. And so I would always recommend so I could do something like this. So see what I did here is I created intermediate variables for basically all the 3 steps. I squared the first side of the triangle, I squared the second side of the triangle, I added them together, and then I do my square root here to print the results out. This is what I would say close to about as explicit step-by-step as you're going to get. In fact, maybe I would do, instead I need to make sure I could do this too. I can do that instead. I can do every step. Sorry, my fingers are dancing here. I can do every step explicitly like that. If I did this right, I should get the same answer, right? Instead, would help. No parenthesis. If this happens to you, right, I'm kind of just showing you it's quite normal, right? It's like forget semicolons, you forget end lines, you forget parentheses, and you just, you tweak it, right? So there's my same answer, okay? This is probably overdoing it. But I will tell you that I've seen many pieces of code where somebody will do something like this, and they have a bug, right? They did something wrong here, right? Maybe they had A3 twice. Maybe there's the parentheses weren't lining up properly, and they're stuck. Break things up into steps to help you troubleshoot your program. For our simple Pythagorean theorem, using the power command is probably overkill. So instead, let's just do this instead. C3 equals square root of A3 times A3 plus B3 times B3. So we get the same answer. This is a great function, and it works for, anything, really. But for Pythagorean theorem, it's a level of complexity you don't need. It is also, and this is something you'll cover as you get into CS201, for example, using that math function is way more quote-unquote expensive in terms of memory usage and CPU speed usage than just taking the variable you've already declared and multiplying it by itself. So we don't care here, and the run time here in Replit, it's not a factor. But if you were going to run millions and millions of these calculations, you would see a noticeable difference. So knowing when to use the math function versus pulling out specifically what you need is an important kind of distinction, if you will. Okay, let's keep going here. Let's jump back to the books here and see there's something else. So go through these math functions, right, and look to see, what might be happening here. And then you have a more complicated example that does an exponential growth calculation. Could be also a financial growth, right? You can do something like this with your interest rate on your car, for example. And here's Pythagorean theorem, which I had not realized was in the book before I used it as an example. But you can see here we're using the power statements here as examples, but we don't have to, right? Okay, here's an example of calling the power statement inside the power statement if you want to do this, right? Some more examples. Distance between 2 points is a kind of a more complicated, same type of algebra as Pythagorean theorem, right? Okay, so now we'll jump to integer division, and we'll kind of come back to the problem that I started us with, right? So if you look at this example here in 3.2.1, you see, we're doing an integer 10 divided by 4. We get an answer of 2, not 2.5. An integer division of 3 divided by 4, we get an answer of 0, not 3/4. Okay, so these are some more examples of what I'm showing here. Okay, and you will make this mistake. You will forget this, right? And the reason I know this is because I see experienced software developers forgetting this from time to time, myself included. your mindset is doing something, and you put your simple code in, and all of a sudden you're getting 0 when you should be getting 0.8 or something like that, and then you try to divide and you get a division by 0 error, and your program it craps out, and you go and work through it, and then when you realize your error, it's a forehead slap, right? So if you want to do floating point division, you need to have at least one of those operands be a floating point. And that's what I was showing you here, right? Okay, so some more examples that you should run through. All right, let's talk about using how to get the remainder. Okay, remember the pizza slice calculation you did, right? If each pizza feeds, I don't remember what the numbers were. Each pizza feeds 4 people, but if you have 13 people, you're going to have some pizza left over, right? And so this is when you do integer division, and you don't have you have some partial amount left over. That's called the remainder, right? And so the way that you calculate or determine the remainder in many languages is to use the percent operator. Okay, if you've not seen the percent operator used like this, then it's an important point to note that you don't use the percent operator when you're trying to represent percentage numbers. Doesn't work. The percentage symbol, Shift 5 on your keyboard, right, is in C++ reserved to do the remainder or the modulo operator. And many programming languages use that. Not every language, right? So you might have used double slash, for example, for integer division. You might have to use a function call, mod function call, to get your remainder. But in C++, this is what you get. So let's try that and make sure that works. 11 divided by 4 is 2 with a remainder of 3, right? Because 2 times 4 is 8. 11 minus 8 is 3. Okay, notice that I have my cout statement spanning 2 lines of code. I could do that instead. Okay, let's look at this carefully. If I just have my single line of code, what you see here is it wraps around, and it's still all in line 78 here. The problem with this is it, from a visual perspective, messes up your indentation. It doesn't technically mess up the indentation because it's a wraparound, but from a visual perspective, it messes up the indentation. So I always recommend I broke the rule here, right? I broke the rule here. I would recommend forcing line breaks in your code. This is more readable, at least to me. Now you have to be careful where you force the break, right? If you force the break inside a double quote, let's see what happens here. I get errors here, right? Because here's a string literal without an ending quote. And notice that this is on line 79. So it actually didn't do what I wanted here. So instead, I can do it here, right? I can do it like that if I want. This may not be very readable here because I have my square root function split across 2 lines. So I would do it here instead, right? Now I have my font bigger, right? So my line wrapping is going to happen more than normal, because normally you would be coding kind of like this and you'd have plenty of space, right? but because you're watching, I have a big screen and you're watching your video maybe on your phone or something, I want to have this zoomed in enough so that it's readable. But you can always, and like the see out redirect symbol, right? It could be here or it could be here, right? But this helps with the formatting. I would encourage that. Okay, so we got our remainder. That worked, I think, didn't it? Let's go back to it. Yeah, it was there. Remainder of 3. Okay, so knowing when to do this is a pretty handy piece of knowledge. Like I remember doing high school and college math, and I knew how to do the remainder, but I like really never needed it. But there's a lot of programming examples where you're always using module to get the remainder. It's surprisingly common, is what I've learned. Okay, let's talk about division by 0. Okay, period. It's one of the worst bugs in software because it happens so often and it can be difficult to check all cases. Division by zeros can be exploited to cause crashes. Similar to memory leaks, you could use them to, find your way into software and cause havoc. The failure of a division by 0 is going to depend on your development environment. So for example, if I do this and I run this, it tells me, right? It says, hey, you're trying to divide by 0. The compiler has figured that out before I even try to run the program. So that's awesome that it does that. Okay, but of course, if the compiler doesn't know what the number that, there's little value in like hard coding division in your code, right? Instead, you're going to often do something like this. Let's try this. Okay, so I'm going to enter my number. I'll enter 6. 10 divided by 6 is an integer. Integer division is 1. So that worked. Now let's try this. And I'll enter 0. And notice what happened. It was fast. You may not have noticed it. So let me run it again. Okay, 2 things happened here. One is this guy switched from running, because right now the program's running, right? And so I could stop it manually if I want, but as soon as I enter that 0, it immediately stopped. The other thing is that we got this warning sign here, the exclamation mark inside the triangle here, and if I mouse over it, it says, hey, your program quit, command terminated by a floating point exception. Okay, so it's not telling you exactly what happens. Now, if I just quickly go to another replit, let's see what we got here. I got some students' code in here. All right. Let's do a quick Python thing. I guess I don't need to do that, huh? Okay, what did I do wrong here? I can only, oh, all right. Python forces me to make these guys strings. This may or may not look familiar to you, right? If you took CS160, of course it should. But now let's try to run 0. Let's see what happens here. Okay, so in this case, Python tells me division by 0. So that's helpful. That's way more helpful than this, right? Which is what happened. You may not even notice the dang thing stopped running. And only if you're looking over here will you see this. Every development environment is different. Visual Studio, I think, tells you explicitly it's a division by 0. Okay, so the notification and it might even be possible for me to change something in Replit to do that for C++. I just don't know. You're basically seeing the level of my capability on Replit. I can do interactive stuff like this, but I haven't done any heavy development on Replit. My heavier development is either command line and text files or Visual Studio. Hopefully we'll show some Visual Studio stuff in this other video that I'll be working on. All right, let's move on. Let's look at the book here real quick and see if there's anything else. We talked about modulo, integer vision. All right, parentheses, we are going to cover that, so I'm going to keep going. And a good example here. Remember, do these examples. If I wanted to spend more time here, we would do each one of these interactively, but I'm expecting you to do these, and you could pause the video and do this for example, right? We're going to move on to type conversions. Okay, so we've been doing a little bit of informal type conversions. What a type conversion is taking a piece of data and changing it into a different data type. So I might have an integer piece of data and I might change it into floating point. Or I might have a character data and I might change it into integer. Okay, sometimes this stuff happens, it just happens where it makes sense, right? So let's do an example here. A7 double B sub. And I'm specifically mixing floats and doubles here. So I am going to comment this guy out so that I don't have to keep entering numbers here. I'll make a note here. I'll share the code, right? And so you'll see that comment there. And I gotta comment that out because I'm not using that variable. Okay, 35.33 is my answer here. Let's just double check that. 32.33 plus 3 gets me 35.333333. I subtracted 3, so I really should have 35.33033. That's our full answer. But I have, if we go up, I have a set precision here of 2 here. So let's change that to a bigger number. And you can see that it's what I did there, okay? So in this case, just like we were showing you earlier, this math function ultimately produced a floating point number even though one of the variables was integer. Okay, And so you got to be careful. No, I don't have it in mind exactly what to do. If you have more complicated formula here and you do something with two integers, let's try that. Double D8. See what happens here. Okay, if you look at what happens here, I get the same, nope, I get 33. So in other words, I take my 32.33 and I add this value which evaluates to 1. And then I add the C7. And the reason is it because it does integer math inside here. Right? So again, just like my previous example, you have to be careful about that. Okay. The other thing I want to show you here, so this is an example of implicit type conversions. In other words, the software is doing what it thinks it needs to do. Okay, we're going to talk about explicit in a moment here. When I convert, but before I do that, note that if I convert from double float to int, I will drop the decimal value. So notice that 3.99 converted to 3. So it doesn't matter if it's 3.00001, 3.2, 3.5, 3.6, 3.9, or 3.9999999999999. I can add some more 9s here. Still should do the same thing. It still drops it. Okay, and this can get confusing in your code if I have fewer decimal points of viewable precision. And it's like, what the heck is that? Look at that. In conversion of 4 is 3. You look at that and you think, oh, I have a big problem here. Now what's happened here is because I'm only printing A8 up to 4 decimal points, it rounds up. So remember that set precision is not a calculation. It's just a formatting thing. And it does round. So you got to be really careful here, because what's really happening here is this 0.999999 is getting dropped. And if you print the value, you think it's rounding up. Okay, so pausing here for a moment. Try this out, try a few things, change the set precision numbers, etc. Okay, but if you want to round the number, fortunately the math library has a a round function. Let's see if that works. Still didn't, see? It still didn't round it. That's because I didn't print it. All right. Sometimes I wish it would just fix and know exactly what I want to do there. Okay, so why didn't that work? Oh, because I didn't use the round function. Sorry. There we go. So now we rounded it, right? So you can use the round, or there is this cool trick. A8 equals 3.51. Okay, so that worked here. What I did was, sorry, I zoomed that out. Let's do it that way. I took my value and I added 0.5 to it. Just think through all the values. If you're dropping the decimal and you want to round, as long as if you add 0.5 to it, anything 0.5 and above will be the next integer. So when you drop it to that integer, you've effectively rounded up. It's a clever little trick here if you don't want to use the round statement. Okay, I just introduced a new I guess it's technically an operator here that's running on this called static cast. Okay, and what static cast is doing is it's forcing this, whatever this is, into this data type. This is also demonstrating the explicit conversion using static cast. So cast is, the term cast in this case means that it's a type casting is explicitly going from one data type to another data type. Okay, so if we go into section 3.3 here, type conversions, and you follow through, you're going to cover a lot of what we just went through. Here's another example using static cast. You don't always need to use static cast. Again, sometimes it will happen implicitly, right? But you should go through these examples here. All right. Section 3.4 talks about binary. And I'm not going to go through this. This is the same concepts that we covered early on in CS160. If you don't remember this stuff or you want a refresher on this, you go back and look at some of your stuff from CS160. Maybe you still have your little flipper tool, your flippy-do tool, right? Which you can see, is illustrated here. I'm gonna go. I have a note, and I'm gonna go look at my standalone videos for CS160 and see if I have a good one to post, and I'll include it with this when I post this. And so you can get a refresher on binary if you need it. Okay, but you can also, of course, go through this, right, as a good refresher. But we're going to move to characters because dealing with, make a note here, skipping binary, review your CS160 stuff. Characters. Dealing with non-numeric characters, or I should say non-numeric data, in C++ can be confusing. If you go onto the internet and you start to try to figure out how to do all this stuff, there are chars, strings, strings, those are two different things, char arrays, pointers, etc. All sorts of stuff. This is further complicated by what I call the zealot soapbox characters that are on the internet sites such as Stack Overflow. Okay, if you've tried to find something on Stack Overflow for an introductory class like this, I'll give you some credit because it's not hard to get overwhelmed with the zealots who basically tell you have to do it their way, and it's only their way that works. I taught very early in CS160, and I'm saying it again here, that there's like dozens of ways to do anything in any piece of software programming. And in many cases, there's no right answer. And in many cases, there are multiple ways to do it that are equally valid. And if the Stack Overflow guy says, oh, you should never use string because of blah, 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 then that person needs to take a break and go into timeout and recognize that there are uses for all of these different methods. We're not going to worry about that too much. Like I've always said, you just need to be consistent. So if you're using lowercase s strings and uppercase s strings and you're mixing them without telling me why, that's a problem. Okay, we won't be doing much of that anyway, but I want to introduce the concept as being more complicated than we might think if we just went through the material in the book. So let's talk about the char data type. Char stands for character. Okay. This is a character literal, right? And so it's a fixed value, right? It's a just like saying 3.51 here. The character A here is a fixed literal. It's in single quotes. Okay, so if I want to print this out, I get my character that I'm printing out correctly. Okay, now remember that all data stored as bits. Okay, so let's try this. So again, this is where we would do an exercise if we're all in the class and I'd look for a show of hands. You know, is this going to work? Is it not going to work? Is it going to give an error? Is it going to, what's it going to print? So let's see. No, there's no maybe. Of course it's doing it. It's going to do whatever it does. Okay, possible answers here are error. This might error out. It might change to A1. It might change to 1. It might change to B. Right, those are all the possible things that people might be thinking. And it changed it to B. Okay, so the reason why this worked is because A is defined as a set of as a binary value, and that's governed by this thing called the ASCII encoding, which some of you certainly are familiar with. And because it's logical and it makes sense, the binary code for B is one more than the binary code for C or A. And then the binary code for C is one more than the binary code for B. It doesn't have to be that way, but it does make sense, right? And so we've established that that's true. But now let's try this. Static cast int C9. So let's see what happens here. 98. Okay, so lowercase a is 97, lowercase b is 98. All right, so why? I'm just going to go into Google and I'm going to search for ASCII or ASCII table. We covered this in CS160. You've probably seen this before. So let's kind of look. Let's look here. Here's the capitals. Here's the lowercase. So B, decimal value of 98. Right? So now if I wanted to convert from uppercase to lowercase, right? An uppercase A is 65, a lowercase a is 97. So if I took my value and I added 22, I would convert an uppercase to a lowercase. If I took 80 and I added 22 to it, I'd get 112, right? So I'd take my uppercase P to my lowercase p. So converting something from upper to lowercase is not that difficult, or vice versa. Okay, if you have characters that are the numbers, notice that the character value of 4 is 52. It's not 4. So that's important as well, because characters are not the same as integers. Okay, also note that are not the same thing. Okay, that's important as well. Okay, let's do behave. The operator, the plus operator behaves differently with strings. Okay, so in the case of characters, the plus operator does an integer modification of the binary value of the string. But if I do this instead, see what happens here. You can see what happened here is it basically combined all these things. And that's what was happening on that Python code that I showed you earlier. Actually, I closed the tab. But this is actually doing a combination of placing the strings after each other. And the term is called concatenation. Also concat, or just sometimes cat. Okay, so that's a big difference here, right? So if I did it this way instead, double quotes, and I tried to do this, I get an error, right? So this exact same code right here does not work on strings, even if my string's just one character in length. Okay, so we can put that in a comment here. Oops, this will fail. Okay. And we get all sorts of craziness here, right? Basic string parameter against int. It's like it gets me a lot, right? It just jumps through it here and gives me that same error over and over and over here. This is another interesting point. Like if you get a lot of errors here, the best thing to do is start at the top, because here it's showing the line of code under suspicion, and it's saying this is the most useful piece here, right? Versus candidate templates and deduced conflicting types and all this nonsense, right? Which will just give you a headache here. So instead, you see here, hey, I'm trying to use string and int together, and it's not working. Okay. Also with strings, sometimes spaces are trouble. let's try that. Okay, so here I'll say hello there, and I only get hello. Okay, so when I use the cn command, cn will stop when it hits a space, which I think is nuts. I mean, that's not how I would have designed it, but that's what happens here. Okay, and so I want to point out here, so if I go down further here, okay, we've covered that. There's an ASCII table here built into the book. Can walk through some of this stuff. It's just a little bit more on the characters. And then we talk about strings. Okay, and there's some input of strings here. And here's a heading that says getting a string with white space from input. Right? So if I want to enter two words and I want it to go into the same string, I can't use cn like I just described. There's a function called getLine here that you can use. And I'm just going to suggest that you walk through this example versus me doing it here. And then there's some differences between cn and getLine. This stuff can be tricky. And so it's really important that you go through these one at a time to make sure you're following that. If we continue to section 7, the book introduces this thing called an input stream. And it talks about what happens if I want to input a lot of things into different data types. And you can kind of see the difference here between, like, if I want to have 2 or 3 variables in the same cn statement. This stuff can get pretty tricky. And then there's a way to get just single characters. And this is as you get into more fancy input processing, where you might say, hey, I want to get a letter one at a time. We're doing some code here we haven't talked about here, which is this concept of this while loop. And here's a function that will automatically convert the letter to an uppercase letter. So it's kind of a cool function. You can try it. A little bit more advanced than where we're at right now. There's a couple other functions, one of which is called peek, which is a way to look ahead without pulling it. And so cn, getLine, peek, etc. are ways for you to do more and more advanced input processing. I've learned that if I go through all those details now, we get a bunch of glazed overhead eyes, and it's not until you want to implement this stuff where it really starts to stick. So I'm gonna stop with just the basic cn stuff that I'm showing here. Okay. What I do want to do is talk a little bit about input validation next. Okay, and this may be where you find that I'm, compared to some of the other instructors, I'm going to be more aware, and I'm going to be looking for ways to break your code. As somebody who has code in the field, out in the wild, with teams that have developed, programs and thousands of lines and millions of lines of code out in the field, that code has to work. Right? And it has to work even if you got bad guys trying to break it in different ways, or just users that just, enter the wrong thing, or the data file has the wrong stuff in it. Okay, so I'm going to be very, very consistent about saying, hey, the code doesn't work if, right? And while I don't expect you to do all this input validation here on these early assignments, by the time you're done with the class, I kind of expect you to be able to do all 3 of the following things. I talk about 3 types of bad input. One is what I call invalid input. The data matches the data type, but the value is nonsense. I'm just typing this stuff out versus having PowerPoint slides here, right? Example, I ask you to enter your dog's age, and you enter -3. Okay. So if I'm not checking for that, and you enter -3, something's going to happen, and it could be bad or it could be confusing. if you enter -3. Okay? Invalid input, the data matches the data type, but will create a fatal error if not caught. This is where I would pause and say, what's an example of that? And I expect all of you at the same time to say division by 0. Okay, that's an example of that type of invalid input. And then the third is what I call illegal input. The data entered is the wrong type for what is being asked. Example, I ask you to enter your dog's age, and you enter Bosco, which is one of my dog's name. Okay. And so what will happen there is, I'm going to take the quotes out. What will happen there is going to be totally dependent on the program, right? It might crash. It might not assign the variable, and then that will fail later. It might find a number somewhere else. All right. There's cases where if I did that, it might get the number 0 out of that, right? So number 1 and 2 are much easier to catch and manage than number 3. And so I'm expecting by the end of the class that you are able to catch these types of bad inputs. And a good outcome is every type of bad input I try to break your program is one step ahead of me. And it says, sorry, you can't answer that, please try again. Or sorry, that doesn't work, I'm quitting, etc. Okay? So that's a little bit about input validation. This is talking about some of the things that may fail. And so as you go through these examples, you'll be able to connect to what I just described. Yeah, we could cover this real quickly. Overflow. Okay. I think most of you know that an overflow is when a number gets too big to fit in the space that's allocated for that. Okay, and if you think back, 15 years ago, there was a lot of worries about Y2K because people were using a two-digit number to store the year, and when we rolled over, we were then, we had a number that was too big. It's a version of overflow here. Okay, and so here's a common error. Trying to store an integer value greater than 2 billion into an int variable. Okay, so we could actually try this. I think we could try this. I'm going to say int, where am I at? A9 equals power you see how often I get my angle brackets backwards despite coding in C++ for years? So if you do it too, you can join the club. Oh, I gotta take that out. Where is that? Where is that? Two to the 33rd power is not 1. Two to the 34th power is not 1. Okay. change this a little bit. This is a fun code to write once you learn how to do loops. Notice that when I did the couts directly, I got my answers, and you can see that these numbers, as I went through, they more or less they doubled, right? You don't have to do the full math, but you could see 5 went to 10, 10.7 went to 21.4 to 42, right? You could see that, right? But if I put static cast int around that, faster just to modify it this way. Let's see what happens here. Yep, so we get to what I was showing you earlier. So we get 2 to the 29th, which is, I wish we could put commas here, right? So those are so 536 million. Then I get to 1.07 billion, and then I get 1, 1, 1. It'd be nice if it told me there was a problem, right? But it doesn't, right? So what happens here is an integer variable is 32 bits long. Okay, so if the int variable is 32 bits, then 2 to the 32 is about 4 billion. So why does overflow start at 2 billion? I thought that that should work. Okay, we'll skip that for now. Why does overflow start at 2 billion when 2 to the 32 carry 4 billion? This is because our int data type supports negative numbers. Thus, 32-bit int covers approx negative 2 billion to positive 2 billion. And it's actually negative 2 billion to positive 2 billion minus 1, technically, because you got to count, get 0 in there directly. We don't cover signed complement or 2's complement in CS160 anymore. And so dealing with negative numbers and how they're measured in binary, we don't cover that in CS160 anymore. We used to. And so it's a interesting concept that if you're interested more, you can look into it. But we're not going to cover it really in here either. But what you see here is C++ is not helping, right? It's doing the function, but it's creating an overflow and not catching it. Okay, and so if you do this, you'll see something similar here. It says here, most compilers detect a state when a statement assigns a literal constant to cause overflow. So let's try that. Let's try that. Int a10 equals no, it doesn't work. Seriously? Okay. All right, let's see what happens. Let's see if the compiler can detect this. Implicit conversion from long to int changes the value from 4 billion to 0. right? So it is catching that, and it doesn't let me run that. So that's good. Okay, so sometimes you get a warning, which means the program still runs. Replit generally is strong about all warnings are errors, which I think is good because I don't like to see warnings. And this is what this is. This is saying the same thing here. Okay, and so this could happen when you don't think it needs to happen. So here's a good example, right? If I have three large values, but I'm calculating the average of them, in theory, I can have three large numbers that are between 1 and 2 billion to calculate the average of those. But if I added them together, I'm going to get over 2 billion. It's going to cause a problem before I do the division by 3. And so again, you have to be careful about that. There is a different data type where you can have a longer, what's called a long int or a long int, which are larger capacity ints. Okay, and so you can see here, we've moved to 310 here. You can see, so you have int, which we've talked about. Here's our exact numbers right here. Okay, I would say that almost in most of your development environments, an int is going to be 32 bits. There's one notable exception of that, which is if you're building on Arduinos. And so if you're using the Arduino IDE and you're doing some stuff on Arduinos, you got to be careful. The data sizes aren't the same thing. And I think I showed an example of one of those in one of the earlier videos here. But if there's interest to see some more about that, let me know, and we could do something here. But if you're going to be dealing with these large values that are above 2 billion, then you can use what's called the long, which is a 64-bit value, and that gets you these astronomically high values here. Okay, and this is important to know that long. Yeah, it's long. It's not just long. If you look here, the long variable type is the same as int. And that's because in the olden days, ints were less than 32 bits. Okay. So go through that. We're not going to talk about the floating point precision right now. The next section talks about formatting. And we talked about I/O manipulation already, so you can watch that video. But I want to show you floating point here momentarily here. Okay, so we have, stop. We already covered cout fixed set precision with some number. We already covered that right here. So let's try this. A10 equals, let's see, 99,999. Not sure the number matters. Let's see what happens when I print that. It rounded it up. Okay. So now this gave me my scientific notation if you want. Okay. I take a few decimal points out of this. You can see this way it printed it correctly here. So it's tricky to get your exact precision when you're using the scientific notation. There are additional kind of qualifications you can give here. If I go back to fixed mode, it's going to keep the same set precision that I already had. Here's another example where what's being printed is not what's actually in the system. Again, it can be a cause of a bug here. So just going back to fixed will remember what you set it to last time. I think, if I remember right, we talk about it here. Fixed scientific set precision. There's also the showing the decimal point if you want, even if the fraction's 0, which you sometimes need to do. All right, this next section here is really cool. I like this stuff. This is where you can take strings and you can pretty print your tables. In CS160, there's that assignment 3, I think it is, where you're doing parallel lists and you're like doing entering song artists and titles or class score, students in their classes or whatever, and you're printing things out. And some students figure out how to print kind of like in this really cool format here where everything's lined up. And you do that using these set width commands. And there's two things in here that I want to point out, right? You got this set width, which basically says that I'm going to print the I'm going to print the 2 months, which is a literal, left justified in a width that's 10 characters wide. Let's check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we print a vertical bar, right? And then we print this guy right justified. That's what the lefts and the rights mean. And then you also have this cool thing called set fill, where I could basically print the same character a bunch of times, right? Like this. Okay, so you should try this. Some cool stuff to format your code, or not your code, but your output. Okay, the rest of the chapter here, I think we're getting close to the end. There's some random number stuff. There's some talk about debugging. Again, I'm going to get you a different video on that. And then there's the stuff as we jump into the labs here. I wanted to stop at the formatting. I think that's some useful stuff as you're doing text. All right, so I think with that, we'll be good for now. Questions on Module 3, don't hesitate to post. And looking forward to seeing what you do with this.